Well, hello once again, and here we are with our example of Week 11 MyStatsLab Problem 4 from your homework. In this problem, a consumer magazine listed the price and power of auto batteries. We want to know if more expensive batteries are generally better in terms of starting power. Alright, and we have our regression and residual output they have given us here, and we can use this to answer the questions they're going to ask us. Okay, part A. How many batteries were tested? Well, you see here that the degrees of freedom, say 19 minus 2 equals 17. So that tells us that there were a total of 19 batteries that were tested. Part B, are the conditions for inference satisfied? Let's take a look at them. First is the linear assumption. Using the scatter plot for power from above, we can say that this is satisfied because the data follows a straight trend. So it seems to be trending up here. The independence assumption, using the residual plot for predicted cost from above, the second one here, we see the absence of patterns, clumps, and trends. So this is satisfied. Equal variance assumption, using the residual plot for predicted cost from above, the same one. We can tell the spread around the line is nearly constant, so this assumption is satisfied along the line here. And then finally, normal population assumption, using the residual plot for normal scores from above, we see the plot appears straight, so the assumption is satisfied. Let's take a look at that. And as we can see here, pretty much a straight line as we go along. So that takes care of that. Okay, moving along. Part C. Is there evidence of an association between the cost and cranking power of batteries? We're to test an appropriate hypothesis and state your conclusion, and we're going to assume that alpha is 0.05. So we're going to start off by stating our null hypothesis is that there is no linear relationship between cost and power. B sub 1 equals 0. And if that's the case, then our alternate hypothesis will be that power increases with cost. So B sub 1 is going to be greater than 0. So let's look at it this way. Using the p-value for the cost from the regression output above to determine our conclusion. If we go back up, and we see here p-value for our cost at 0.162. We're going to divide that by 2 as I did here, and we get our p-value to be 0.0081. And since this p-value is so small, we know that we will reject the null hypothesis. Part D. What is the equation of the regression line using the equation y hat equals BO plus B1 times X, same one we've been using. And since the dependent variable is power, it's going to be equal to, and let's get our numbers here, intercept is 405.654, cost is 4.16852. So using those in our equation, we see that power is equal to 405.654 plus 4.16852 times the cost. Part E. Create a 90% confidence interval for the slope of the true line. And for this, we're going to need our critical t and our standard error. Well, as I've shown before and we'll use again, we're going to use the website I have listed here to do the critical T for us. Here's the website. We know our degrees of freedom from our problem is 17. We also know that the probability level on this one, it asks us for a 90% confidence interval, so we change that to 0.10. Calculate here, and we get our t value to be 1.7396, and we will round that off to 1.740. Now our standard error comes from the output that we have above. We can get back to that. And we see the standard error for our cost at 1.564. Now with those two pieces, we can go ahead and calculate our confidence interval, our lower limit, as you see in our formula here, again using 4.16852 minus our critical T times our standard error, and we get our lower limit of 1.45. Using it again for our upper limit, 4.16852 times our critical T and our standard error again, this time adding it to the 4.16, we get our upper limit at 6.89, and that tells us that our 90% confidence interval is 1.45 to 6.89, which leads us to part F, and we will say we are 90% confident that the mean power increases by between 1.45 and 9.89 cranking amps for each additional dollar in cost. Well, there you have it. That's your example for problem 4. Hope this helps out. And as always, if you have questions, you know you can always ask.